All right, let's dive into something that sounds like it's straight out of science fiction, but is getting closer to reality every single day: the quantum internet. And just to be clear, this isn't about getting faster downloads. Nope, this is about completely rebuilding the foundation of our digital security from the ground up. So, how on earth do you build an unhackable internet? Well, let's get into it.
Just think about that for a second. Every single thing you've ever sent that was secure, your bank details, private messages, corporate secrets, even classified government files. What if all of that could just be cracked open? That's not just a scary thought. It's the very threat that's pushing scientists and nations to race towards this whole new kind of network. And here's the really chilling part. The danger isn't in some distant future. It's happening right now. It's a strategy called harvest now, decrypt later. Basically, adversaries are sucking up and hoarding massive amounts of our encrypted data today, and they're just sitting on it, waiting for the day when a quantum computer is powerful enough to unlock it all. So the messages you send today could absolutely be read tomorrow.
So, this brings us right to the heart of the matter: the quantum threat. We need to understand why our current encryption, the stuff that has protected us for decades, is suddenly facing a complete existential crisis. This right here shows the massive shift in thinking. Our current internet is built on bits. They're either a 0 or a 1. Its security relies on math problems that are just way too hard for even our best supercomputers to solve. But the quantum internet, it uses something called qubits, and its security isn't based on hard math. It's based on the fundamental, unbreakable laws of physics. It's the difference between a lock that's really, really hard to pick and a lock that screams bloody murder the second an unauthorized person even touches it. And here's the problem in a nutshell. Once we have a powerful enough quantum computer, an algorithm, specifically something called Shor's algorithm, will make our current encryption look like a child's puzzle. It will essentially be a master key that can unlock the systems that protect everything from our financial markets to our national security. But here is the beautiful, almost poetic twist. The same weird, mind-bending quantum physics that creates this terrifying threat also gives us the perfect solution. So let's meet the spooky new tools that are going to build our secure future. Everything starts with a qubit. A normal bit in your computer is like a light switch, right? It's either on or it's off. A 1 or a 0. Simple. A qubit, thanks to a wild property called superposition, is more like a spinning coin. While it's in the air, it's not heads or tails. It's kind of both at the same time. That ability to hold multiple values at once is what gives quantum systems their incredible power. And if you thought that was weird, hold on. Next up is entanglement. This is where you can take two qubits and link them in this deep, mysterious way. Their fates become intertwined. If you measure one and find out its state, you instantly know the state of the other one, even if it's on the other side of the galaxy. It's not a signal, there's no travel time, it's just an instant connection. In fact, this was so bizarre, so counterintuitive, that Albert Einstein himself couldn't get his head around it. He famously called it spooky action at a distance. He wasn't a fan. But it turns out this spooky action is the absolute key to making the quantum internet work. So, how does this all add up to unbreakable security? Well, it's because two fundamental laws of physics are basically your security guards. First, the no cloning theorem says you simply can't make a perfect copy of a qubit. Can't be done. Second, the uncertainty principle means that the very act of measuring or even just observing a qubit changes it forever. So what's the result? An eavesdropper can't copy the data, and they can't even look at it without leaving a giant flashing sign that says, "I was here." They get caught every single time. Okay, the physics is mind-bending, for sure. But how do we go from these bizarre concepts to actually building a real-world global network? How do we build the quantum web? Well, the first thing to know is we're not just going to throw out the internet we have today. The plan is to build a hybrid system. Think of it like this. The classical internet we all know and love will still do the heavy lifting, all the routing, the control signals, but we're adding a new specialized quantum layer right alongside it. And its only job is to handle those super fragile qubits and distribute that spooky entanglement I was talking about. But that leads us to probably the single biggest engineering hurdle. Qubits are unbelievably delicate. Sending one down a fiber optic cable is like trying to whisper a secret during a rock concert. After just a couple hundred kilometers, the signal just fizzles out and is gone.
So how in the world are you supposed to send a quantum signal across an ocean?
The answer is a really ingenious piece of tech called a quantum repeater, and it basically uses a divide and conquer strategy. You take a really long distance, say from New York to LA, and you break it up into smaller, more manageable links. In each little link, you create a pair of entangled qubits. But here's the magic trick, a process called entanglement swapping. It lets you take the entanglement from adjacent links and, well, swap it. So the qubit in New York is no longer entangled with the repeater in Ohio. It becomes directly entangled with a qubit in the next station, and so on until you have one unbroken entangled link all the way to LA. You created a long-distance connection without ever sending that fragile qubit on the full journey. It's brilliant.
Now, an unhackable internet is obviously a huge deal, but believe it or not, that's just the opening act. The truly mind-blowing part of the quantum internet is what it will let us do beyond just secure communication. This network is the thread that will connect the entire quantum world. We'll be able to link up smaller, simpler quantum computers and have them work together as one incredibly powerful machine. It will also let us build networks of quantum sensors. Imagine entangling telescopes on different continents to create a virtual telescope the size of the Earth, or connecting atomic clocks so perfectly they create a global time standard that wouldn't lose a second over the entire age of the universe. And to put that into perspective, look at this number, 10,000 times. That's how much more sensitive an MRI scan could become by using a network of these quantum sensors. Just stop and think about what that means for medicine. What could we see inside the human brain? What diseases could we diagnose years, maybe even decades earlier? The potential is just staggering. So, with stakes this high, from unbreakable codes to revolutionary medicine, it is absolutely no surprise that building this thing has kicked off a fierce global competition. This is way more than just a science project. It's a high-stakes race to define the future. And you can see that race in cold, hard cash. China has poured over $15 billion into a very centralized, state-driven push. The US and Europe are also investing billions, but with a different strategy, focusing more on public-private partnerships. But make no mistake, every major power knows that whoever leads in quantum technology could gain a massive economic and strategic advantage for decades to come. But all this progress, all this investment, it forces us to ask a really difficult question. When you have technology this expensive and this complex, there is a very real danger of creating a quantum divide, a world where some nations take this incredible leap forward, while others are left even further behind, potentially more vulnerable than ever before. So that's the thought I want to leave you with. The quantum internet holds the promise of a future that is fundamentally secure, guaranteed by the laws of the universe itself. It's an incredible, powerful vision. But as we race to build it, we have to keep asking ourselves, are we building an unbreakable future for everyone, or just for a select few? That's the challenge that lies ahead.